Okay, now most everybody knows what kickback is that has been in the business for a little while. Is anybody here ever experienced a bad kickback?
I do.
Yeah.
Is when you sharp too low the records.
Well, that could be a cause that would create kickback, but generally speaking, that's not going to actually create the kickback. If you look at this, actually, I'm missing my book. Hang on just a second. You see, it shows you different ways that kickback can occur. Now, most people only think of one way, and that's the one that's on the bottom, and that's called rotational kickback. Now, where a rotational kickback occurs is when the piece of chain that's in between my two fingers here, when that comes in contact with an object. In other words, the typical scenario is, if this is a log right here, and I'm cutting through this log, but I'm not paying attention to where the end of the tip of my saw is, and if I come in contact with a wall or a chain link fence or another piece of wood, this tooth is going to grab and it's going to force the saw right back at you. Okay? That's called rotational kickback. That is the most common type of kickback, and that is the most severe type of kickback because it takes all the power of the saw and transfers it to lifting that bar right back at you. Okay? So that's called rotational kickback. Then the other three are just as important, but maybe depending on the circumstances, not as severe. There's what they call linear kickback, which would be as you're cutting through a piece of wood, if the top of the wood starts to close up, okay, it's going to grab the chain, and if the chain's going full throttle, which way is it going to go? It's going to throw the saw right back at you. Okay? Now this is usually less dangerous than rotational kickback because you usually get hit by the saw in the back of the saw instead of the bar and chain. But depending on where you're standing or how you're standing, that could still be very dangerous because this comes out of there like a bullet. Okay, then the next one is exactly the same as the top one, except they call it pull because that's where the log you're cutting closes up and binds on the bottom of the chain. So what that's going to do is the exact opposite of the linear or the top pinch. It's going to pull the saw and you forward. Now this one can be very dangerous if you don't have good firm footing and the saw jerks you forward. It could pull you into the bar and chain. Okay, so you call that pull. And then if you go down one more, there's just another way, and the push is similar to the linear and the pull, except it usually happens when you're trying to do an undercut. You know, before you're going to cut a branch, you always want to make sure you make an undercut so it doesn't bind. And so if it pinches up here, then it's going to come right down at you. Okay? So chainsaw kickback. Flip over to the next page now. And again, there's going to be another picture. Let's see, it's going to be on the back of that page. Right on the back of that page. You've got a picture there that, again, it's going to talk a little more and show you a little better the different ways you could get rotational kickback. And that rotational kickback is the real dangerous one, the one that you really want to avoid. Now, what has the industry done to try to lessen that? And there's a lot of things that have been done to chain and to chainsaws to lessen the potential for kickback. The first thing is all your chainsaws now have a chain brake on them. Everybody see how that works?
Yeah.
Okay, so the idea behind this is with your hand like this, if the chainsaw starts to kick back on you, your wrist hits it, stops the chain, and you just get smacked in the head by a non-moving bar and chain, which is definitely preferable than a moving chain. Okay, but that's the primary purpose of the chain brake. You know, a lot of people think it's a hand guard to keep your hand away from there, but the purpose of the chain brake is so that as it rotates around and it hits you, then it's going to engage the brake and stop the chain. Now, what's going to happen if you're cutting like this and it gets kicked back? Anybody have any idea? Is the chain brake going to help you? Now, if you're holding it like this, if it kicks back, there's no way your hand is going to energize the brake. Now, this is where it gets very tricky, because most all the chainsaws, and specifically all the stills, which I think everything you use is a still, have what they call a secondary brake system. It's called an inertia brake. So that if you're cutting like this and the saw violently jerks back, like it's kicking back, that is going to trigger the brake automatically. Now, why is that so important? Where that is so important is if you have the chainsaw, say you got it tethered, okay, and maybe you didn't put the brake on when you were pulling it up the tether, okay, so you knew down at the bottom that the brake wasn't on, okay, but as you're pulling the saw up, it hits a branch. Remember what I said? Any sudden jarring movement, what's it going to do? It's going to put the brake on. Then when you get the saw all the way up and you squeeze the trigger, oh, wait a minute, the chain's not going. But you know you didn't put the brake on. But what you have to remember is that the brake can go on by itself anytime it receives a jarring movement. Okay, so whenever you have a situation where the chain won't move, the very first thing you want to do is check the brake, and you check it simply by pulling it back. If it clicks, and it's always a definite click, I mean, you hear that sound, it has to make that sound. If it's not making that sound, it's not working. Okay, so it needs to be a loud clicking sound, but always double check that. Now you say, well, okay, why am I spending all the time to talk to you about that? That's because Blair just is going to have to pay, what was it, $290, almost $300 to repair one of your saws that was ran with the brake on. Now, what happens to the saw, how this brake works, is it's a band that clamps around the sprocket that turns the chain. It just literally clamps onto it solid. So if you have the brake in the on position and you try squeezing the trigger, the clutch is still going to try to engage, but it can't turn the drum because the brake is on. And the more times or the longer you squeeze the trigger, the more heat builds up in there. And before you know it, like in the case of the saw that he brought in, it melted the little bearing that the sprocket rides on. It melted the oiler gear, and it melted the actual oiler itself. So it does quite a bit of damage. So you always want to make sure that you understand how the chain brake works and what can set it off and what can't set it off. Okay? And the main thing is these things are tricky. You know, for you guys that are working on the ground, it could be something as simple as setting it down hard on the ground. That could trigger the chain brake. But when you pick it up, you didn't put the brake on. So when you squeeze the trigger and the chain doesn't move, you keep squeezing the trigger. Well, always double check that brake first. Okay, the chain brake is probably one of the best safety features on a chainsaw, but it could also be very costly. And it could do quite a bit of damage to the saw itself if you try throttling up the machine with the brake on. The same thing is true if you have a chainsaw. You know, if I were to start the saw and just let it sit here, it should idle. And when it's running at idle, the chain should not be moving. Okay, so if you had a saw though that maybe the idle was set a little too high and the chain was moving, but you put the brake on to stop the chain, what's that going to do? Yeah, remember we just went over that. It's going to really heat that up. Okay, when that gets heated up enough, it's going to start melting things down. So, you know, if you've got a chain where the chain does not stop, a saw where the chain does not stop moving, always make sure you adjust the idle down, okay, to stop the chain, not use the brake to stop the chain.
So maybe that's what happened to the 036.
It's entirely possible that that's what happened to that.
So are we just talking about
I guess-
020 or any chainsaw that
Any chainsaw.
Okay.
Any chainsaw. So what I'm telling you is basic generic information for all the chainsaws. And it's even more so, on your bigger saws, because the bigger the saw, the bigger the engine, the bigger the clutch, the bigger the brake band. So that stuff could really transfer heat real fast.
And the more expensive it is to
The more
fix.
expensive it is to fix it. Yeah. Now, one comment that I always get is people ask, well, why did they start making so many of the chainsaw parts out of plastic? Does anybody here have a good idea why they make the chainsaws out of plastic?
To
Be lighter?
Make them lighter. That's the first assumption that most everybody makes. But there's actually a different reason for that. And the reason is, in the old days, you'd buy a chainsaw and it would only last, under commercial use, maybe only 2 or 3 years. And then it'd be worn out, you throw it away, you'd get a new one. But now these saws are lasting a lot longer. They're lasting 5, 10 years. But what happens is anytime you cut anything in the palm or the yucca family, you know what I'm talking about?
Yes.
And everybody knows what a palm is. Well, anything in the yucca family too, which could be some of the cacti, and there's some, they got some variants of, like it's sort of a cross between a palm and a yucca. But anything in those families, when you work on them, you always have to make sure you wear long sleeve shirts so that you don't get that dust on you. And always make sure you wear a respirator. Very important. You don't want to get that dust down your lungs because it's very acidic. Okay, but what the chainsaw manufacturers found out is that was so acidic that it would actually eat the aluminum magnesium alloy that the saws used to be made of. So, you'd have all of these guys with these great big saws that had leaks in the oil tank, or leak in the gas tank, because the palm acid is actually eaten right through the metal. And that is actually the primary reason that you see so many more plastics, especially in the area underneath here, where, when you're cutting, all the debris goes. That's where it's really important to have a lot of plastics. Have any of you seen a saw that was damaged by a palm?
especially the big ones.
Yeah.
This is in a plastic.
Yeah, metal, and it gets all pitted, huh? Yeah. So, it's...
The 090's like that.
what's a good idea to do?
Okay,
The
if
change doesn't have plastic here. It's
you actually need to use a 50% baking soda, 50% water solution. It's not like, okay, I only made 1 or 2 cuts, but you still got enough acid in there where it's going to start doing some damage.
Even when it's a trim, when you're just trimming the palm?
Even if you're just trimming. Yeah. Because see, it's not acidic when it's not with moisture. Like when you cut through a palm, it's real moist. But when you're trimming it, there's not much moisture there. It's dry out there. But what happens is, you get a lot of oil thrown up underneath here. Well, when that hits the oil, that gives it the moisture to create the acid. Yeah, so even if it's dry. Now, you see this chain here?
Yeah.
Okay, everybody would like to buy this. You'd have to have a real big size motor for that. Anytime you see a chain with a green link in it, okay, now you've seen chains with green links, and you've seen chains with yellow links. Okay? The green link means it's a reduced kickback chain. And how this reduced kickback chain works, now come in close here, because you're all going to need to see this. This is the part, obviously this is the tooth, this is what cuts. Okay, now remember I told you that the rotational kickback is going to occur right there. Okay, so now this little link right here, this is like that big green piece, you see? This little link right here is called the anti-kickback link. Now you'll notice that when it's in the cutting mode, either on this side or this side of the bar, that link is flat, and it's the same height as the depth gauge breaker. Okay, So it's not doing anything. It's just sitting there. But watch this link right here as I start to roll it around the end of the bar. What does it do? It starts to stick out further than the depth gauge. And when it gets to this point right here, it actually prohibits the tooth from cutting. Okay? Now, what does that mean to you? That means that when you're cutting and you come in contact with something at the end of the bar there, instead of the tooth being able to grab into it and throw itself back, this little ramp makes the material just run over the top of the tooth. Okay? But now, what happens though, how many of you make boring cuts? I don't mean cuts that aren't interesting. I mean boring, you know, like you're boring deep, you know, going straight down into the wood like this, where you're trying to cut with the tip.
Like for a palm, a date palm, you have to push it in.
Yeah. You get what I mean?
I know who used to do it. You gave me.
But if you try to cut with the end of this bar, what's going to happen? It's not going to want to cut, right? And it's not going to want to cut because that little safety ramp is sticking up there and it's keeping the tooth from cutting. So if you take this saw and you stick it in a piece of wood and you try to cut with it and you push on it, the only thing you're going to do is you're going to heat up this little sprocket in here, damage the sprocket, and it won't cut. So if you're going to try to use a chainsaw to make boring cuts, what do you have to do? You have to use a chain that does not have this link in it. You need to use one of the yellow chains that does not have this little safety ramp link in it. Okay, that's why sometimes different saws will have different chains on them, and that's one of the biggest reasons. Is, you know, number one, this is probably, I hesitate to use the word safety, but this is probably one of the safest chains to use on a chainsaw. It's going to cut much smoother than a non-safety link chain, and if you do run into a kickback situation, it's going to be much more forgiving than a non-safety link chain. But you would not use this chain if you had to do bore cuts. Because if you're going to do bore cuts, I don't know, did you guys do those? Do you ever run into them?
Not too often. Just
Yeah, it sort of depends on what part of the country you were trained in. Because there is some parts of the country when they go to cut down a tree, they start by making a bore cut and then work their way around. They call that apple coring. And that's one thing that I really don't recommend. And, you know, basically the way your saws are set up, they're not made to do that anyway.
We can just that one. Then we're just that cut.
Yeah, that's good. That's good. That's a good cut to avoid. Okay, now I want to talk a little bit about. They stole my sample on my saw chains. Okay, we're going to look at two different kinds of teeth. Okay, now can you look at these and see what the difference is? Yeah, this is more rounded, okay, and this is more square. Okay, some people call this homeowner chain, and some people call this professional chain. I don't like to do that, because this is probably the best chain for most all-around use. Because with this chain here, with the rounded radius right here, you have a much bigger cutting surface. So that if you get into a little abrasive dirt or something, this is going to stay sharp longer. Whereas if you take this tooth here, this very tip, the very point here, that's the only thing that has to be sharp when it cuts. So the minute you hit a little rock or something and you dull this little point, the performance of this chain just nosedives. Where if you were using this chain here, you've got such a much bigger area that it's cutting that you can keep cutting a lot longer. Now, say if you were a logger and you were working up in the redwoods, say you were falling big redwoods, which chain would you want to use? You'd want to use this one because you're paid by the board foot of lumber that you cut. But if you guys have ever seen a regular faller work, out in a logging operation, I don't mean a tree service company, but you'll notice that the very first thing they do when they come up to a tree is they'll chip the bark away from around the tree where they're going to be cutting. Now, why do they do that?
So don't damage the chain.
Because they don't want to damage the chain. What's in the bark?
Nails.
All the dirt and the debris, all of that stuff. So they chip that all away, and then they start their cut. They're cutting through nice.
They clean the skin of the tree.
Yeah,
right?
they basically skin the tree before they stick their saw in there. Because they're running real long bars, and you don't want to have to stop and sit and sharpen that. Because every time you stop to sharpen, you're not cutting wood, which means you're not adding to your board foot of lumber by the day. So that's why they like this. But again, the minute they hit something, like if you get a tree that was spiked, you get the tree huggers that come out and put the nails in the tree. The minute you hit a nail, this is gone. I mean, it's completely dull. Whereas this one, you could probably keep going a little bit. So basically, you got to get this notion out of your head that this is professional and this is homeowner. It really isn't. It really depends on the kind of wood you're cutting. If somebody was telling me, well, I got to cut some nice, clean redwood. The other way to look at this is a lot of people like to use this in softwoods, and they like to use this one in hardwoods. And unfortunately, we got both in this area. So I say, don't use this chain, use this chain. The other thing is that this has to be sharpened differently than this one. And if you look at you got a page that looks like this. Get
so
that one out.
like the 84 of it.
Everybody should have. Yeah, you've all got it. Okay. Now there's some things that are real critical here that everybody needs to understand, and that is that wrench isn't going to stay there. That is, it's extremely important that you get the right chain that matches. There's two things, or actually three things that have to match. The end of the sprocket has to match the chain. Okay. The part of the sprocket that's on the chainsaw has to match the chain, and then the chain width, the thickness of this link has to match the groove of the bar. Now, if you look at the top, the pitch, which is the distance between the links, the pitch is what it talks about in the very top box there. And there's 1, 2, 3, 4 different pitches that you can have on a chainsaw.
I don't think I don't have the page.
It's probably on the...
What page is it?
Oh, wait a minute. No, you don't have that page.
It says bars and sprockets? No.
No, this one you don't have. I'll print you up some of these before we leave. But when you talk about the pitch and the gauge, those have to match and they have to be right. A lot of times customers come in here and they say, I need a chain for my chainsaw. Okay.
Something else?
That doesn't tell me anything. But, if they can usually tell you how long the bar and chain is and what brand it is, you can usually get a pretty good idea of what chain it might take. But, a lot of chainsaws use a variety of chains. That's why I usually tell people, if you need a new chain, bring the old one in. Or if it's like with your company, we know what saws you have, we know what bars and chains you use. That's a little different, but it's usually where we run into trouble is with the homeowners.